There is a line inside your wall. You cannot see it, cannot smell it, cannot touch it. And it decides whether this wall lasts 50 years or rots from the inside in 5. Let us find it layer by layer. Every wall has a temperature gradient, warm inside and cold outside. Your room air has a dew point, a single temperature. Where the wall temperature equals the dew point is a line. That glowing line is the dew point plane. The critical thing to understand, it is not a material. It is not in the spec sheet. The plane is an imaginary isotherm. Its position is decided by 4 inputs: indoor temperature, indoor dew point, outdoor temperature, and the R value of every layer. Build the wall layer by layer. Drywall, vapor retarder on the warm side, insulation between the studs, sheathing, cladding. Now watch the temperature drop across it, and watch where it lands, on the sheathing. Right there. The sheathing interface sits at or just below the dew point. Vapor migrating outward reaches that cold surface and condenses, invisible from the room, accumulating inside the wall. The sheathing is the condensation surface. Now move the insulation. Same wall, same R value, but push the insulation to the outside of the sheathing. Watch the gradient redraw. The sheathing is now inside the warm envelope, and the dew point plane slides outward, away from the structure. The sheathing is now above the dew point. It is no longer a condensation surface. The plane sits harmlessly in vapor-permeable exterior insulation that can dry to the outside. The structure is protected because it lives on the warm side of the line. The dew point plane moves with conditions. A colder exterior slides it inward. A higher indoor dew point also slides it inward. Milder weather can push it out of the assembly entirely. The line is never fixed. In cold climates, the warm side vapor retarder goes on the interior side of the insulation, slowing vapor before it reaches the cold zone where the dew point plane sits. Place it correctly, and the wall stays dry. Common error: sealing both sides with low permeance layers. A vapor impermeable layer on the cold side traps vapor against warm side materials that cannot dry. Any moisture from leaks or air leakage is locked inside. A wall that gets wet must be able to dry. The warm side slows wetting. The cold side permits drying. Balance the layers around the dew point plane, and the assembly can manage moisture over time. Disclaimer: this video explains building physics principles for reference only. It is not a design specification. Consult local codes and a qualified professional for your assembly. Next in the series, node C01-008.